Hello and welcome to a new video. My name is Herwig and today I show you my 5-step roadmap for metal to plastic conversion. So a lot of us polymer engineers were already tasked or had already the idea, including myself, to make metal replacement. And the big question is immer how to make that in a constructive way, in a structured way, and where to start and where to end, and what are some important in-between steps. And it's the reason and also motivation for this video to get all this and make some kind of a roadmap or flowchart, which allows you to guide you through the single steps of a metal to plastic conversion, metal replacement. Okay, let's jump right in. The flowchart consists out of 5 steps, and I will link it below for you to download then this chart also. So we start with the first step, metal part identification. So I need to find the right metal part I want to replace, and what I'm going to do is I tear down the metal part, the metal application, to understand it. It can be that it's only one component. It can be that it consists out of several components. And what I do in this step is to identify the metal components which can be replaced. And here some guiding questions are, what do you want to achieve? So here we also already take up some preliminary requirements and set some boundary conditions. So is it that I want to have more weight out, so less weight, less costs involved? And once I have done this, I identified the components I want to replace, I start with a feasibility study. This can be technical, so using also simulation tools like finite element analysis, and also in this phase I can start already towards polymer material selection to identify potential plastic materials. And when the outcome is that it's not feasible to replace it because mechanical loads are too much or some other reason, then we cancel it here. So we will not continue. If the outcome of this first feasibility study is yes, we see some chances, then we continue. And here, the next step is then to estimate the plastic component costs. So we take some pricing of the plastic itself, the material, and also the manufacturing, like injection molding, to get the price which then is comparable to the current metal price. And then the next big question is there a cost advantage compared to the metal component? If no, then we also cancel. Here in this phase, we also check for part and function integration. So in order for us to, for example, eliminate multiple metal components, and because this puts out the perspective also on the costs when I can replace 2 free metal components with 1 injection molded parts. And I also try to map out the additional benefits, such as, we mentioned it already, weight out and also noise reduction, for example. If you have there a yes, then comes the next step. Now we start really with a detailed CAD design of the plastic component, because it is different compared to metal to design a plastic part. And here we start again with virtual engineering and also virtual testing of then our CAD design. And this virtual testing allows us also to finalize our material choice. So we still may have 2 free materials, and in this phase we can really then be sure to just pick 1 or 2 for the next step, because then we can do again a detailed system cost estimation. So we know now the polymer we want to use. We know also the manufacturing process, and if there is secondary operation like assembly is involved, assembly costs. So, and once this is done, we have again a quick check. Is there a cost advantage compared to metal component? No. Then we stop, we cancel again. If the outcome is yes, then let's continue. What is then the next step? We go into prototyping. So really prototype tooling, soft tooling, make some producer molded parts. And once we have the parts, we go into part testing. So there we test the part itself, and then also when we put it into the component of systems and test all over system. Once this is done, the new part can be released and the introduction of the serial production can start. And that are basically the main steps of a metal to plastic conversion. So let's go again up. We start with metal part identification. We tear it down. We identify the metal components which can be replaced. Start with a small feasibility study, focusing on the technical side. Is it feasible to replace? Yes. We continue. We make a estimation of the plastic component costs. We have the costs. Is there a cost advantage? Yes. Are there additional benefits identified? For example, check for the part integration, multiple metal components replaced by one injection molded part. Yes. Then we start really with the plastic part design and start with virtual testing. We can make filling simulation, and this allows us then to finalize the material itself, so the polymer material selection. Then we again make a cost estimation, short check, is there still a cost advantage compared to metal component? Yes, we continue. Now we start prototyping, so we need a tool, soft tool. We produce parts, we test the part, we evaluate the whole system, and then we release the part and can start with the serial production. Okay, I hope you enjoyed this video. It was useful for you, and if you need help to get your metal to plastic conversion started, please reach out to me. And I would like to thank you for watching, and see you in the next video. Bye. Thanks.